So here we go with the first numerical of worksheet 4. So a stone is released from the roof of an elevator going up with an acceleration of 5 meters per second square. So for this, let us assume a lift in which a stone is being released. Okay? Yes. So inside a lift, a stone is simply released. So definitely the stone will fall down. When the stone is released, the stone will fall down. But what it was given is that the elevator, that means the lift, is going up. The elevator is going up. So that means it is accelerating upwards. And its acceleration was given as 5 meters per second square. The value of A is given as 5 meters per second square. So the acceleration of the stone after the release is, children, if you observe that, does the stone maintaining any contact between the lift? Obviously no. So when there is no contact between the stone and the lift, so this is taken as a non-inertial frame of reference. So only forces that are acting on the stone is the weight of the stone itself. The weight of the stone is only because of the acceleration due to gravity. Whenever acceleration due to gravity G acts on the mass of the stone, then the weight is given by mg. So because of which the body falls downwards. So the acceleration of the stone is only because of the acceleration due to gravity. So acceleration due to gravity is indicated with the letter G. Okay. And the stone will be falling downwards. Okay. So the acceleration on the stone will be the value of G, which is acting downwards. So what is the value of G, children? The value of G is given as 9.8 meters per second square, and the stone falls downwards. Hence, option 4 must be true. So now moving to the next question, question number 2. A man weighing 65 kg force is in a lift that is ascending with a uniform acceleration. Ascending means going up again. So the lift is moving upwards with uniform acceleration, not uniform velocity, uniform acceleration. So some acceleration is there, which is equal to acceleration due to gravity. The value of A is given as G. His apparent weight in the lift will be. So first of all, so this is your lift, and inside the lift again a man is there. Yes. A man weighing 65 kg force. Children, what is kg force? This you need to understand, children. Always remember that 1 kg force is nothing but 1 G. 1 kg force means 1 G. Its value is 1 into 9.8 or 9.8 newtons. This, remember this always. Okay. So meaning of 1 kg force means 1 G. So, or it can be written as 1 into 9.8, which is equals to 9.8 newtons. Suppose if you are given 5 kg force means 5 into G. 5 into 9.8. That please keep it in mind. So man weighing 65 kg force is in a lift. 65 kg force means his weight is equals to 65 G. W equals to 65 G. So mass is equals to 65 G by G. That is 65. That's it. Okay. So clearly the value of given that weight is equals to 65 kgf. This is nothing but 65 G. If weight means mg is equals to 65 G, then mass is nothing but 65 kgs. Hope you understand this. Kg force 65 G. Okay. Weight means mg, 65 G. So mass is 65 kg. That's it. So it indicates that the mass is 65 kg. Keep it aside. Given that the lift is moving, accelerating upwards, ascending means moving upwards with an acceleration equals to acceleration due to gravity. The value of A is given as G. His apparent weight in the lift will be. Children, whenever the lift is moving upwards, we know that the reaction force is given by R is equals to M into G plus A. So you remember this formula? m into g plus a. And the value of acceleration A is given as g. Therefore, its apparent weight R is equals to mass is 65 into g plus acceleration is also given as g, or R can be written as 65 into 2g, or R is equals to 2 into 65 is 130g. So what is the value of R? We got it as 130g. But if you observe in options, either it is given as 0 or kgf. Children, I told you that 1g can be written as 1 kgf. So 130g can also be written as 130 kgf. Hence, the correct answer is the apparent weight in the lift is 130 kgf. Hence, the fourth option must be true. Clear? Well, moving to the next question. A person of mass 60 kg is in a lift. So, again, picturize a lift in which there is a person whose mass is given as yes, 60 kg. Mass of the man is given as 60 kg. Over. The change in the apparent weight of the person when the lift moving up with acceleration of 2 meters per second and then down with an acceleration of 2 meters per second square. The change you are asked to find out. So first of all, suppose that when the lift is moving upwards, case 1. Okay, first case, if you observe, first case, when the lift is moving upwards, upward motion. During an upward motion, we found the value of R as m into g plus a. Yes? Well, so this R is equals to man's mass is 60, gravity is g, g value let us substitute as 10 simply, 9.8 also will get the same answer because difference they are asking, plus 2, or R can be written as 10 plus 2 is 12, 12 into 60. Okay. So, answer is R is equals to 720 newtons. Clear? M into G plus A. M is 60, G is 10. I suppose G as 10 and A is given as 2 meters per second square. So, we got the value of R as 720 newtons. So, this is the case when the lift is moving upwards. R and mg mass. Suppose if the same lift is moving downwards. The lift is, second case, moving down. Okay, for the second case, moving downwards, the net force, the reaction force is given as how much, children? M into G plus A, sorry, G minus A, downwards na, G minus A. That means here, formula, mg minus R is equals to ma, so R is equals to m into G minus A. So, this resultant force is given as mass is 60, G, let me take it as 10 and minus 2. So, R dash is equals to 60 into 10 minus 2 is 8, or R dash is equals to 480 newtons. So, earlier here it was 720 newtons and now when it was moving downwards, it was found to be 480 newtons. But you are asked to find the change in apparent weight. Change in apparent, this was the old weight and this is the new weight. So, change in apparent weight is given by delta R, which is equals to R minus R dash, is nothing but 720 Newton minus 480 Newtons. So, what was the answer, children? Yes, it is 240 Newton. Hence, the correct option is option 2. So, apparent change in the apparent weight. This was the first apparent weight. This was the second apparent weight. Difference in the two apparent weights is 240 newtons. Now, the fourth question. a 6 kg object is suspended by a vertical string from the ceiling of an elevator. Let us picturize this, children. So again, you have an elevator, okay, from the ceiling of an elevator. From the ceiling of an elevator, what is given? A 6 kg object is being 6 kg suspended from the ceiling, which is accelerating upwards. So this lift is given, it is accelerating upwards at a rate of 21.8 meter per second square. Acceleration value was also given, moving upwards. The tension in the string is, there must be some tension acting in the string. So clearly, if you picturize this 6 kg mass, its weight is acting downwards. The tension must be acting upwards and the acceleration is acting upwards. So this, based on the free body diagram, if you drop out the equation as it is moving upwards, T minus mg must be equals to ma, or T must be equals to m into g plus a. Substituting the values, m is taken as 6, g is taken as anything of your choice, maybe 10 or 9.8. This is 21.8. So T is found to be 6 into 10 plus 21 is 31.8, or T is equals to 190.8 Newtons. So the value of T is found to be 190.8 Newtons. But there is no such option which was given. So but our value, the proper value what we have got according to the given data is nothing but 190.8. Maybe some correction with the numerical we have to apply, children. There is a mistake in the numerical itself. Okay. Options. Either the question must be changed, the options must be changed. Anyhow, based on the given data, the result for tension we got it as 190.8 Newton. So please note down this, children. So well, moving to the next question. A pendulum bob is hanging from the roof of an elevator. Elevator means again the lift. So there is a lift inside which a pendulum bob is being hanging over with the help of a light string. When the elevator moves up with uniform acceleration A. So what is happening? The elevator is moving up with acceleration A. The tension in the string was found to be T1. And when the elevator is moving down with acceleration, two different cases. One is moving up, second case moving down, two different cases. Here the tension was found to be T2 and here first case the tension was found to be T1. So if the elevator was stationary, case 3, the elevator was stationary, the tension in the string would be. So stationary means acceleration is 0. So this is the first case, second case and third case tension was found to be T3. So if the tension in the string would be, so whenever the elevator is stationary, you are asked to find out the tension. So you have some relation between the two. Let us find it out. Okay. First of all, case A. When the elevator is, first case, when the elevator is moving upwards. Three different cases, children. So for an upward motion, let us picturize this. Okay. So tension T, mg downwards, accelerating upwards. So equation for this is written as T is equals to, or T minus mg equals to MA, or T can be written as M into G plus A. But in the first case, as it is moving upwards, the tension was given as T1. So T1 is found to be how much? M into G plus A. Case 2. Case 2. Where is the case 2, children? When this elevator is moving downwards. So for the downward motion, tension upwards, weight downwards, acceleration downwards. So downward force is greater means mg minus t equals to ma. Bring the t other side, ma this side. So t can be written as mg minus ma, or t is equals to m times of g minus a. But case 2, when it is moving downwards, the tension was given as T2. So let us name this as T2. Earlier it was T1 and now it was T2. So now you're asked to find out whenever the lift was at rest. Case 3, children. So when the lift is at rest, okay? Whenever the lift is at rest, so no acceleration, a is equals to 0. Okay, so the upward force is balanced by the downward force, that is t must be equals to mg. So this new tension, okay, this new tension you are asked to find out. Let me name it as t. So what is the value of t, children? You have to use t1 and t2. So concentrate on this. So what was the value here? Let this be equation 1 and this be equation 2. Suppose if you add the two equations 1 and 2, okay? So if you add equation 1 and 2, what is left hand side here? T1. What is the left hand side in the second case? T2. So T1 plus T2 will be equals to, now let us add the right side. Right side what is there? mg plus ma. Again here right side what is there? mg minus ma. So simplifying this, we have minus ma plus ma cancel. Therefore T1 plus T2 equals to 2mg. If T1 plus T2 equals to 2mg, then what is the value of mg, children? So what is that? We have T1 plus T2 equals to 2mg. So mg will be equals to T1 plus T2 by 2. Therefore mg can be written as T1 plus T2 by 2. Hence the relation between the tension acting in the lift when it is at rest, moving upward, downward means T must be equals to T1 plus T2 by 2. Hence the first option is true. Upward motion calculate, downward motion calculate, add the two things, you get the value relation between T1 and T2. So find the value of mg. Substitute the value of mg. Over. So moving to the next question, sixth one. When a lift is going up with uniform acceleration, the apparent weight of a person is W1. Lift moving upwards. When the lift is stationary, W2. When the lift falls freely, apparent weight is W3. Lift going down with uniform acceleration, less than, apparent weight is W4. So you have to write all the things in the increasing order. Over. So children, case 1. Apparent weight, instead of tension, they named it as W1 for upward motion. I won't be writing everything, children, simply write down. Upward motion, when the first case, when the lift is moving upwards, normal reaction or tension in the string, whatever is there, is given by W1 is equals to M into G plus A. Remember this formula I gave you? So upward motion, apparent weight is given by M into G plus A. Case 2. Over. When the lift is stationary, case 2 is regarding the stationary lift. Whenever the lift is stationary, okay, the apparent weight, they themselves named it as W2. We took it as R earlier, they named it as W2. Stationary means A is 0, rest condition, then W2 will be equals to mg. Case 3. When the lift falls freely means just the acceleration will be equals to g, freely falling. So acceleration of the lift is equals to acceleration due to gravity. First example, stone we have considered. Okay, so in that case W3 is equals to m, downward motion, falling down means m into g minus a is your formula, but instead of a we have to substitute a as g. So g minus g. So what is the value here? It will be 0. So W3 will be 0. Fourth one. Okay. Down with the case 3. When the lift is going down, now the last case, the lift is going down with the uniform acceleration less than acceleration due to gravity. So that means case 4 means downward motion. For downward motion, we have W4 is equals to m into g minus a. A is lesser than g, it was given. Okay, so we know W1, W2, W3, W4. The increasing order of these 4 weights is, so among all the things, which is smaller, children? This one is smaller. Okay, because you'll be getting positive value here because a is less than g. So first one, W3 is the least value. So W3 is less compared to all values. Now mg minus ma, which is smaller? Mg minus ma. So W4. Then mg means W2. Highest is m into g plus a, that is W1. So this is your increasing order. You're asked to write down in increasing order. So smallest, largest, in between. So which is the correct option? 3, 4, 2, 1. Yes, option 2 must be true. W3, W4, W2, W1. Well, moving to the next question. A man weighs 80 kg. What is the mass of the man given? 80 kg. He stands on a weighing scale in a lift which is moving upwards. Okay, mass is given. Weighing scale means that weighing machine. This is moving upwards with uniform acceleration of 5 meters per second square. What would be the reading on the scale? Yes. So that concept, whatever we have discussed, children, there must be some weighing machine on which a man is being standing. And it was also given that the lift is moving upwards with uniform acceleration. So clearly the reaction force because of the weighing machine is acting upwards and the weight of the man is acting downwards. Equation of motion is given by R minus mg equals to ma, or R is equals to m into g plus a. This is our formula. So you're asked to find the reading on the weighing machine or weighing scale. So what is the reading? R can be given as mass of the man is 80, G value is 10, A value is 5. So R equals to 80 into 15, or the value of R is 120 newtons. Value of R is found to be, sorry, one more 0 is there. So 1200 newtons. So the right option is option number 3. So direct formula, substitute the values to get the answer. Well, moving to the 8th question. A body of mass 2 kg is hung on a spring balance mounted vertically in a lift. So what is that, children? So there is a mass. This is acting on a spring balance and that is hanging vertically in a lift. If the lift descends means moving downwards, ascends means moving upwards with some acceleration whose value is equals to acceleration due to gravity. The reading on the spring is, imagine the lift in which a spring balance is kept. I'm drawing the spring balance here. Yes. A body of mass to which a body of mass, how much? 2 kg is being hanging. And it was also given that the lift is moving downwards. Clear? So you're asked to find the reading on the spring balance. This reading, whatever it is showing, you have to find out. Let me represent that reading on the spring balance as R. So no doubt its weight is acting downwards. So whenever the lift is moving downwards, equation is given as mg minus r equals to ma, or simply r can be written as m into g minus a. So whenever the lift moves downwards, equation is given as R equals to M into G minus A. So this reading on the spring balance you're asked to find out, whose mass M is given as 2 kg, value of G itself is G, A itself, they gave the value of A as G. So G minus G, so what is the value of G minus G? 0. Hence anything into 0, if you observe, R is equals to 2 into 0 is 0. Hence the correct option is 0. Is that okay, children? That's all. So the reading on the spring balance is 0.